Previously we've covered FK transforms. We have also covered adding nodes to our network, but before adding anything further to the network, I'm going to cover weight-based deformation, which we can also refer to as skinning our rig or weighting our rig. To make this easier to work with, I've updated the network. This will prevent changes made in one network from breaking the functionality of another network. An example of this would be where I changed names in a previous video, and this breaks the rig, as the bone names no longer match names in the weights. These updates are straightforward, and I'll not be going through any of these updates in depth. They are also KineFX updates rather than Apex updates, and we will be working with various different skeleton sets in the future, which do not match up with these. So first, I'll look at updating our network in the context of the auto-rigger. This update will be very straightforward. We'll get an auto-rigger node. This is of course the Apex auto-rig component. By default, this node is set to bone deform, and bone deform is exactly what it sounds like, and that is what we're currently dealing with. This node can work for our other network, but the updates will not necessarily always work, as the updates do depend on components' names. I can connect this to our network. Most of the parameters will be the same. We can refresh the component parameters, and this will allow us to update the default names. Here this will not really matter, as the geometry which we have already generated is using the default names already. Most of this is pretty standard. The main thing to pay attention to here is actually the point transform node, as this is a node within our network, and this is our most likely place of having a name clash. If we look at the unpacked network, we can search for this node, and this will be just before our output. This is referring to the set point transform node, which is what we're currently using to update our FK controls, as well as our skeleton. So it would be easy enough to use this node with the custom network, which is not something which I'm going to cover now, as we do not need to use the auto-rigger components when making a fully custom network in any case. So once again, for the basic setup, once this node is connected, we can refresh the component parameters, and this will allow us to change the default references. And the main node in the network that we'll be looking for here will be the point transform node, and here we'll be connecting to the .geo input. We could take a look at the updated network, but I'm not going to do that now, as we will be constructing this manually. We can now test the network. To do this, I'll get a scene animate node. We could also access this with the icons on the side of the screen using the animate button. I'll connect the node and I'll reset the inputs. I can then rotate my joints, and the mesh should be deformed with the skeleton. So that's how we'd approach this with the auto-rigger nodes. I'll now work on the other network where I'll set this up manually. Previously, I looked at starting to add nodes dynamically. We'll not be dealing with that yet. Instead, we're going to add this manually. So I'm going to add this with my base rig setup, which I'm creating in the edit graph node. We have 3 transform object nodes, and these are creating our FK transforms. The set transforms node is updating these, as well as updating our skeleton. So we want to use this information to drive our mesh geometry, and I'm going to do this with a single node, and this is the bone deform node. For this node, we're primarily concerned with the first 3 inputs. Most of the other settings will not usually need to be updated. One of the most important of these is the other attributes option. However, this is usually used for generating pose-based deforms, and I'll usually generate these before this part of the rig in any case. The other main thing that I'd look at here is the method, as dual quaternion interpolation usually gives better results than linear interpolation. However, when using the game engine, you want to know if the game engine supports this first, as this is not always the case. Essentially, this node is exactly the same as the standard bone deform SOP. It's only the type of the parameter inputs that looks different, as this interface does not have drop-down menus. So we can get the bone deform node. As I said, we're essentially adding this node to our network. Over here, the skinning method would be the method option, and this would usually be set to either linear or dual quaternion, and when you're working on film, you can do more complex blends between these 2 methods. The other main option I'd use here would be the other attributes, where I could use this to pass transform attributes into our deformed geometry. So essentially, this is the same node. One has just been driven through the Apex network. So I can now connect this node. I will be updating my inputs more than I probably should, as I'm a bit picky about the layout of inputs, and unfortunately we can't actually reorder inputs. So I'll connect one of my parameter inputs to the first input of the bone deform node. I'll then connect the output geometry from this node to our output node. This input is getting our mesh which we are deforming. The second input can be connected to my parameters as well. This will be specifically for my skeleton. The third piece of geometry will be for my controls, and this will be set by my set point transform node. I'm going to reconnect the geometry input for this node, as I prefer to have my geometry inputs together. I'll then remove my first geometry input by connecting it to a port and disconnecting it. And this is because I like having my inputs grouped. This is actually pedantic and it is actually not necessary, and it is purely personal preference. I'll change the color of the solver for the moment. I'll then need to update the naming for the inputs and the outputs. So once again, we have our base.reg, our base.shape, and our base.skeleton. The base.shape represents our mesh, and the base.skeleton represents our skeleton. This is the geometry that we want to reference within our input. So we can now update our inputs and outputs. I'll start with the inputs. We will reference our mesh with base.shape. For the skeleton, we'll use base.skeleton. I'll also need to rename the outputs. I'm going to swap around the outputs so that they have the same order as the inputs. Once again, this is pedantic, but I prefer to work this way. The bone deform node will be deforming my mesh, so this will be connected to base.shape. The point transform will be transforming my skeleton, and this will be connected with base.scale. This should be all that is needed to get the skeleton to deform the mesh. Once again, we'll have our bone deform, and this will take 3 pieces of geometry. The first will be the mesh, the second will be the skeleton, and the third is my controls, although in this case it's probably more appropriate to say that this is actually the deformed skeleton, and this will be outputting a deformation to my mesh. The controls will still need to set the skeleton, as we'll need to update the skeleton itself. Our FK controls are setting the controls within the viewport, which are of course deforming the geometry in the set point transform node. I can now test to see if this will work, and currently my network is not actually working at all. And this is because I've made a very basic mistake, and this is a result of me updating the connections within the network. What I managed to do here is bypass my skeleton rest geometry, so I'm not actually creating rest geometry for the skeleton, and the skeleton is not actually moving. I can reconnect this node. I can then reset the animation node, and my mesh should now be deformed by my skeleton. This is how we'll set up basic deformation within Apex. The next thing that I'm going to do is take a look at one of the control mechanisms for the rig, and that is the abstract control system.